In engineering practices today, it is important to note that the shape of the driven gear has a significant effect on the kind of motion that will be generated when the gear is connected to the load. So it could be said that motion has gone beyond a point where the load needs to be connected in such a way that it will be concentric with the driven gears. It is important to note that varying angle has a significant effect on the type of motion that will be produced. So without any further ado, let's get started. There are four common types of mechanical motion today. These are linear motion, rotary motion, reciprocating motion, and oscillating motion. The selection of these motions depends on their application, and it will be important if we look at them one after the other.
Of course, not every load needs a motion that is generally in circular forms. These days, there are great emphasis on those special motion that happens in a timely order. That is, pushing your items at intervals, and opening and closing protective doors in some processes that need little to no exposure to elements, and cutting materials of a certain length at intervals. All these special motion are needed for some special application. Unfortunately, rotary motion is not a perfect fit for this applications. Hence the need.
Now to begin with, linear motion can also be caused by rectilinear motion. That is, it is a one-directional motion that moves along a straight path, and not in a rotary path like the common motion that we know. And it is on this basis that motion of this type can further be divided into two, which are uniform linear motion and nonlinear motion.
Uniform linear motion can be said to be a motion with constant velocity, while non-uniform linear motion is a motion with varied velocity. It is also important to note that there comes some disparity between speed and velocity. Speed is the distance traveled in a given time, and velocity is the distance traveled along a direction. So, velocity without direction is equal to speed. That said, speed can also be called scalar quantity with only magnitude, while velocity is a vector quantity with both magnitude and direction. It is important that speed and velocity are explained, because people tend to look at motion in terms of speed. But in our case here, we are looking at it here in terms of velocity. And because we are dealing with a linear motion that moves in predefined paths, and hence the reason. Mathematically, the distance covered by an object in linear motion can be measured as follows. If x1 is the initial position of an object, and x2 is the final position of an object, then mathematically the displacement can be given as follows.
Now, the next motion is rotary motion. Rotary motion can best be described as a motion that rotates around a fixed axis. This excludes the possibility of an axis changing its orientation.
So, when the motion is rotary, and the axis of rotation is fixed, then that fulfilled all the requirements of a rotary motion. However, rotary motion comes in two forms, which are spin motion and orbital motion. So looking at the earlier definition, that definition describes spin motion. That is because it rotates around its own axis, while orbital motion moves along a circular or elliptical path.
Reciprocating motion, on the other hand, it can also be called reciprocation, or is a repetitive motion. This motion occurs in a timely order.
That is because the motion generated can either be up and down, or back and forth linear motion. This type of motion is usually found in a wide range of mechanisms, which include reciprocating engines and pumps, etc.
That said, the two opposite motions that comprises a single reciprocation cycle are called strokes. A crank can be used to convert into reciprocating motion, or conversely turn reciprocating motion into circular motion.
An example of such can be found in a combustion engine. When the fuel is ignited, the force generated will push the piston down, and the crankshaft turns as a result. The continuing rotation of the crankshaft drives the other piston back up, making it ready for the next cycle. Now, it can be said that the piston moves in a reciprocating motion, while the crankshaft through the connecting rod, it moves in circular, or in a rotary motion.
To further make it sink, when we turn the rotating end by hand, then reciprocating motion will be generated. However, when the piston is pushed downward, a rotary motion will be generated. Now, the last one is oscillating motion. Oscillatory motion is a type of motion that repeats itself. That is, an object oscillates about a fixed equilibrium position, which is usually due to the presence of a torque or restoring force.
In oscillating motion, the torque or force works to return the system toward its equilibrium position, which is regardless of the direction in which the system has been displaced. As a concept and application, oscillatory motion plays a significant role in explaining the action and behavior of electromagnetic waves. Oscillatory motion can further be divided into two, which are linear motion and circular motion. In linear motion, the object is said to move up and down, or left and right. And an excellent example of such motion is the vibration of different strings in a musical instrument. However, in a circular motion, the object is said to move left and right, but specifically in a circular form. An example of such circular motion is the motion of a pendulum in a watch, the motion of a swing on a playground, etc.
And examples of such motion is not limited to an oscillation of a simple pendulum, the movement of spring. However, it can also be said to be in alternating current in electrical equipment, a series of oscillations in the cosmological model, the motion of a wheel, the motion of a solid sphere in a half-hollow sphere, etc. So that is it on today's series. I hope you have learned something new today. See you at the next one.